Hey everyone, welcome back to our YouTube channel. I am Nikhil and today we'll be solving questions from yesterday's Codechef contest, that is Starters 138. So let's begin with our first problem statement. Let's see what the problem statement is saying. So during a scorching heat wave, the temperature in Chefland reached a record high of X degrees, and the next day the recorded temperature was Y degrees. Find whether this was a new record high or not. So they are asking you to check whether the Y degrees is the new recorded high or not. So let's understand the problem statement with the sample input output. So these are all the values of x and these are all the values of y. So can for this pair of x and y, can I say that can I say that 110 is the new recorded high temperature? No, right? I can't say because 135 is greater than 110. So you print no. And when you come to 121 and 121, are they greater or lesser or equal? They are equal, right? They are equal. But for y to be new record temperature, it should be strictly greater, right? It should be strictly greater than x. It should be strictly greater than x. But it is equal here. Hence you end up printing no. So moving to the third test case, it is 101 and 150. Can I say 150 as a new record temperature? Yes, because 101 is less than 150. So you print yes. So how can I write code for this? So a simple pseudocode will look like you will read x and y, and what will you do? You want it to be strictly greater, right? You want value y to be strictly greater than x. So you just check if y greater than x, you print yes, else you print no. So let's try to quickly write the code and submit it. And let's also have a look at the constraints. So x and y belongs to 100 and 150. So they will lie in the range 100 to 150. So I'm going with the scanner class for reading the input from the console. And what is in the input? You should take x and y. So if y is greater than x, what should I print? I should print yes, else I can print no. Let's run it. So it's got successfully executed. So let's submit and check. It got accepted successfully. Let's move to the second problem statement, which is long drive. Let's have a look at the problem statement description. Chef and Chefina are out on a long road trip. The average speed of the car after 10 hours of driving is x kilometers per hour. Chef wants to achieve an average speed of y kilometers per hour. Given that he can travel a maximum of 100 kilometers in 1 hour, we need to find the minimum number of additional integer hours required for him to reach the target average speed. Here, the target average speed refers to y kilometers per hour. So, this is the input format. You can go through it, followed by constraints. Let's have a look at the sample input output. So, we have three test cases followed by different values of x and y. So these are all the values of x and these are all the values of y. Now let's try to have a look at the test case 1 and its explanation. So the average speed after 10 hours is 50 kilometers per hour. This means That chef has traveled a distance of 50 into 10. What is this 50? What is this 50? What is x? That is nothing but a chef's initial average speed, right? And what is this? For 10 hours. That traveled for 10 hours with this much speed. So what will be the total distance traveled? That is nothing but distance equals to speed into time, right? So what is this average speed here? It was 50 and they traveled for 10. That is nothing but 10 hours. So it is going to be 500 kilometers. That's what they are saying here. So if he covers 61 kilometers in the next hour, his average speed would be total distance by, so this was the previous distance and he is going to cover 61 kilometers in the next hour, right? So what now, speed is nothing but distance by time, right? So previously travel distance was 500 and in the next 1 hour is going to travel 61 kilometers extra. As we are talking about the average speed, so we need to take total distance by total time. Previously it was 10 hours, now is going to travel for 1 more hour, so the total time taken will be 11. And if you take this, you are going to get 51 as the average speed which is expected. So to attain average speed of 51, he just need to travel 1 more extra hour. And if you see, they mentioned it very clearly that we should output the integer number of hours only. That means this can be a fraction, but we should just output the integer hours. In that case, you can go for seal of this. Seal. That is nothing but you can just go for the seal of this value. So let's try to understand the problem statement better. So let's say, for example, average speed is just assume that average speed is 10 kilometers per hour. Okay, and I'm traveling with this speed for time as x hours. So what is the distance traveled here? Distance is nothing but speed into time. So what is the speed here? It is 10 kilometers per hour and I'm going to travel for x hours, right? I'm going to travel for x hours. So this will be my distance. So this is fine. So let's consider a linear plane, okay? And consider this as a source and this as your destination. Now, if I'm starting with this as my average speed and if I'm traveling for x hours, what is the total distance traveled? That is 10 into x. So this is the total distance I have traveled with average speed being this and the total time duration being this. Now, from here, from this point, I can reach the destination, okay? But before reaching this destination, I should attain an average speed of y. You should attain an average speed of y. So, and a condition here is you can travel at most for 100 kilometers per hour. If you see, you can travel to attain this average speed that is y, given that he can travel a maximum of 100 kilometers per hour. In 1 hour, he can travel a maximum of 100 kilometers to attain this average speed. This is not a speed, this is average speed. This is not a simple speed. It is the average. Now, okay. Now, Let's try to derive it further. Assume that from this point to this point, that is to reach from this point to this point, you need some, let's say, h hours. Let's go with capital H hours. Okay. Now, time duration here was 10 hours, right? So, till this point, it comes under 10 hours. So, to travel from this point to this point, how many hours you have in your hand? How many hours you have in your hand? Can I say it as alpha minus 10 or h minus 10? As I took h, I'm going with h. Can I say it as h minus 10? Can I say it as h minus 10? You can go with any value here. It's your wish. I'm just taking it as h, as a problem is being asked for extra integer hours. So h minus 10, right? The total hours required from this point to reach destination is h minus 10, right? H minus 10 hours. And for each hour, what is the maximum distance that you can travel? You can travel for 100 kilometers, right? So this was 10 into x, and this will be, so here they said that you can travel 10 kilometers per hour. Here they are saying that to attain this speed, you can travel 100 kilometers per hour. So for these many hours, you can travel, for each hour, you can travel at max of 100 kilometers, right? Now, we know this is the equation to find speed. That is our average speed should be now y, right? Now let's try to replace all the parameters in this equation. So we want our average speed should be y. So I can write it as, I'm just replicating it here. Average speed equals to average distance by average time, right? So everything in terms of average. So here, what is the average speed I want to get here? It is y. And what is the average distance that I covered? That is, first I covered 10 into x kilometers. First I covered 10 into x kilometers, right? I covered 10 into x kilometers, and remaining distance I'm going to cover, that is plus, for these many hours, that is h minus 10 with max of 100 kilometers per hour. And what you need? Average time. So I assume the total time as h. So you'll go with h. Now if you just simply cross multiply, what you're going to get? You're going to get hy 10 into x plus 100h minus 1000. And so what you're going to get here? We are going to get hy minus 100h and 10x minus 1000. So it remains same. And I can take h common here, y minus 100, and this remains 10x minus 1000. So we can write h as 10x minus 1000 by y minus 100. Now, what is this? What is this? What did we assume for h? We assumed it as 10 hours, but we want the average speed from this point, right? From this point. So we don't want this, but our h includes this, if you see. So I'm going to reduce this time, that is minus 10. So what you will get your h as? So let's try to expand it. So 100x minus 1000 minus 10y plus 1000 by y minus 100. Now you're going to cancel them. So you are going to get h as 10 of x minus 5 by taking 10 common here, and then denominator as y minus 100. If you remember, they asked for integer hours. If you see integer hours, so we are going to take seal of this value to get the minimum integer hours. Okay, so if you see minimum number of additional integer hours, that means the resulting value can be a floating point, but we want only the integer hours, so we cannot take a floor of it, right? We cannot take a floor. We can take seal works, right? So let's first declare our scalar class, load input from the console. Then after that, if you see, if you observe the input format, if you first have test cases followed by x and values for each test case. So I'm going to take t here, which denotes number of test cases. Now I am looping over t. Now for each t, I have both inputs, that is x and y, and I'm taking them. After that, what should I do? For each x and y, I should multiply it with 10, and this entire value should be divided by y minus 100, and after that I should take the seal of it, because this might result in a floating point. So first of all, what you have to do? You have to multiply 10 into x minus y, right? Yes. And for this entire thing, you are going to divide it with what value? Y minus 100. That is y minus 100. And this entire thing will result in floating point at times, right? So I'm just storing it in double for now, that is min h. I'm taking it as minimum hours and I'm storing it in the double. Now, but I want seal of this value, right? I want seal of this floating point. So I'm taking a result h variable, a result variable as h, and I want seal of minimum h, which is a floating, and I want this in integer. So I typecast it. After this, I simply print the output, that is h and not min h. For every test case, I'm printing in a new line. Let's run and check. So it got accepted. Let's run, submit it. If you see, it worked. Let's move to the next question. Let's begin with the third problem statement, which is distinct substring. Let's see what the problem statement is saying. Given a binary string is a string consisting of only zeros and ones. We define an island as a substring. Note, point to note, it's a substring consisting of all zeros bounded by ones or the ends of the strings. Okay. So for example, they gave this example. So there are two islands. They are saying, if you see, these three zeros are a substring and they are bounded by this one in one end and this one in the other end. Similarly, you have these zeros bounded by one end and you don't have anyone on the other end because there is no place here, right? And that is nothing but end of the string. Note that the substring 00 in the above string is not an island. They are saying that if you take this substring, or this substring, it's not an island, right? Because if you consider only this substring, you should have a one here to call this as a island. Even here, if you cover this as a substring, we have one over here, but on the other hand, you don't have anything, right? So if you want to consider this as an island, this should be one, right? This zero should be one to consider this substring as a island. So our objective is to find whether there exists a binary string of length n such that there are exactly k islands. That is nothing but you're given it n and k, and the resultant string should have k islands, and each island has a distinct length. That means island should have unique length. The island length shouldn't be repeated. Unique length. The island's length shouldn't be repeated. So to put it simple, if you have a string like this, then you can't call this as an island. You can't count this to an island because you already have an island of length 2. Either this can be 1 or this can be 3. So then if you see, these two are of different lengths. This island is of length 2 and this island is of length 3. So if k is 2, this should be the case. So you have one island of length 2 and you have the other island of length 3. In such way, you have to check whether there are exactly k islands in the string and each island has a distinct length. Okay, let's try to understand this with the sample input output. So we have 4 test cases followed by n and k for each test case. So they are saying for 1 and 1 the output is yes. So let's see the explanation for 1 and 1. So the only binary string satisfying the condition is 0 as it has length 1 and contains one island 0 itself, right? Because either of the ends, so when you take a length 1, you don't have any ones to put on the either reference, right? Because the length is 1. So we are considering 0 as an island. So hence we are printing yes as k is 1. Test case 2. So test case 2, if you see 3 1, consider the binary string 001 of length 3, right? The only island in this string is 00. So what can be the other possibilities for this? They said 001 and here n is 3 as they give and k is 1, right? Now for this, what can be the other possibilities? Can I call this as a valid string? Yes, right? N is 3 and you have exactly one island. Now, can I call this as a valid string? Yes, right? On the other end, you have one and this end, as it's the beginning, we can consider the ends as one. So in this way, I can tell this is also a valid. Now, in the same way, I can also say this as valid, right? And so on. So they only give this, but we all these are also valid strings. Yeah, if you see, they have mentioned it here 0010, what we already wrote here. So yeah, but our condition is to not to check how many possibilities are there. If there is at least one possibility, we should print yes. No matter how many possibilities we have, if there is at least one possibility, we can print yes. Okay. So for test case 3, it is not possible to generate. So what is test case 3? So it is 6 and 3. So 6 and 3, right? So I can start my islands from 1, right? I can start my islands from length 1. Okay, I have took 0, 0, and after this here, as it is the first island, there is no criteria that I should have a 1 year, but there is criteria that I should have 1 year. After that, I will try to form an island of length 2 because I cannot repeat 1. As they said, the island should be of unique length. Now I am going for 2. So if I go for 2, now it should be followed by 1, right? Okay. Now, what is the string length here? This string length is 5. Now, we have only one more space left as per the n, as it is 6. Now, what can be my next island length? It should be 3, right? It cannot be 1, it cannot be 2, it should be only 3. But the available spaces are only 1. Hence, the output is no. Let's try to see for 7 and 2. So, for n as 7 and k as 2, can I say that I will start my first island with length 1? Yes, I can say. And I'll place a 0. And here no need to follow with 1. So after this there should be a 1. I have placed it. Now, what should be my next island length? What should be my next island length? It should be for sure 2, right? It should be for sure 2. Now, this is one island of length 1 and this is one more island of length 2. And how many spaces we are left with? So we are done with 2, right? We are done with 2. Now we are no longer worried about this. We are no longer worried about this. So, but if I place a 1, what all the values can be placed here? What all the values can be placed here? If you see, they asked for exactly k. They asked for exactly k. So, as they asked for exactly k, as we are already done with k islands, that is 1 and 2, I can simply place the ones here. If we have any left for places, we can simply go on placing 1 because we will not consider 1 as a island, right? So, whatever the spaces that are left over, we can just simply replace them with ones, the empty spaces with ones. So, what are we actually doing here? First, we are going for length 1, then 2, then 3, and so on to satisfy exactly k islands, exactly k islands of unique length, of unique length, right? And whatever the resultant string, that should be equals to n. So here, if you see, so this is 1, right? This is 1 and this is 2. So if I want to put one more island here, what will be that length? It is 0 0 0 and the length is going to be 3, and of course you are going to place a 1 here, and if I want to take a fourth island, it is going to be 0 0 0 0 and it is 4, and you'll place 1 and so on. Okay, now 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 if I if I want if I want to know the number of places occupied by zeros, how will I get? It is nothing but 1 plus 2 plus 3 plus 4, right? 1 plus 2 plus 3 plus 4, and this is for when k is 1, and this is when k is 2, and this is when k is 3, when k is 4, right? So can I simply say it as until k times, right? Until k times, can I simply say it as k into k plus 1 by 2? Can I say it as k into k plus 1 by 2? Right? 4 plus 3 plus 2 plus 1, that is nothing but sum of first k natural numbers when you take k as 4, right? So this is one thing, and you get all the indices or the positions occupied by zeros, and we should also worry about ones, right? Okay, now here k is until this point k is 4, until this point k is 4. Now you also want the number of positions occupied by ones. Okay, so for k equals to 4, how many ones do we have? 1, 2, and 3. So can I say it as, so these are number of zeros. Now for some k, can I say I'll have k minus 1 number of ones? Yes, right? If you see here, we have exactly 3 ones, right? For k equals to 4, that is nothing but 4 minus 1. And now when I add them, what should be the condition? Here we are ensuring that islands are of unique length, and we are making sure that islands are bounded by k minus 1 ones. And when I add all of the positions occupied by them, what should be the criteria? They should be satisfying the length n, or they can be less than n as well, right? We have seen for this test case, if you have any leftover spaces, you are going to simply place them with ones because you want exactly k islands only. So I can say it as number of positions occupied by zeros plus k minus 1, that is for number of zeros, and this is number of ones, and this should be either it can be equal to n, even it is okay. If it is less than or equals to n, then also it is fine, right? When it is less than, that means there are empty spaces at the end. You can just simply replace them with ones, which even makes the string as valid. So this will be a condition. If this is satisfied, you will print yes, otherwise. So if else, you're going to print no. So let's dive into the coding part. So if you see, the input is of the form test cases followed by test cases number of lines, with each line having two integers, that is n and k. So first of all, I'm going to take a scanner object. Then after that, I'm going to read the number of test cases. After that, I will loop over the test cases. And after that, for each test case, I will read n. And I will read k. And after that, what was the condition? So number of zeros, right? I'll get number of zeros. I'm taking variable as number of zeros. And number of zeros are nothing but k into k plus 1 by 2. Now I should get number of positions occupied by ones as well. So number of ones equals to k minus 1. So if number of ones plus, no matter the order, number of zeros, if this entire value, if it is equal, it is fine. If it is less than also, it is fine, because we'll just replace the empty spaces with ones. So if this is the case, I'm going to print in a new line saying yes, otherwise I'll print no. So let's run and see. So it got accepted for sample. So let's submit and check. So it got accepted. So let's move to the next question. So here goes our next question, which is prefix suffix inequality. So let's see what the problem statement is saying. So it's saying that you're given an odd integer. Point to note, it is saying it is an odd integer. Okay, it's an odd integer. So we need to generate an array A of n positive integers. So array should contain only positive integers. Array should only contain positive integers. Such that every element lies in this range, and there are some conditions that our array should follow. So let's see what is the first condition. So it is saying that bitwise AND of each prefix array is greater than or equals to bitwise XOR of corresponding prefix array. So prefix AND should be greater than or equals to prefix XOR, right? Let's look into the second condition as well. So it is saying that bitwise AND of each suffix array, that is suffix AND, should be less than or equals to suffix. Here it is prefix and here it is suffix, and should be less. Here it is greater than or equal to, here it is less than or equals to suffix arrays bitwise XOR. Suffix XOR. So this is the condition. So let's have a look at the sample test case as well. So they are also saying that it can be proved that at least one solution always exists If multiple solutions exist, you may print any one of them. So let's now go to the test cases part. So you have three test cases followed by n. If you see, each n is odd. 1 is odd, 3 is odd, and 5 is odd. So for each value of n which is odd, there can be multiple solutions, but this is one possible solutions that they have printed. Okay, so let's have a first test case here. So it is saying for length 1, any array is required range would satisfy all the conditions. So it's very simple, right? There is single element, you just print one, right? Let's move to the second test case, that is 3. So for 3, they consider the array which is 563. Here there is no restriction that you should just go with some set of elements. You can construct any array and you can result any one of them. As they said, multiple solutions exist. Okay, so here they considered it as 563 as the array elements. So they took the prefix arrays bitwise and XOR. If you see, for bitwise XOR and would be same, that is 5. So for 5 and 6, and is 4, which is greater than the XOR, that is 3. 4 is greater than 3, that is and greater than XOR. Similarly here the XOR was 0 and was also 0, so it is satisfying the equal to condition here. Similarly for suffix arrays, you can just have a look over this. Now let's try to understand the problem statement in a better way. So first observation we can make from the problem statement is n is always odd. N is always odd, and the first condition they are saying is prefix and should be greater than or equals to prefix XOR, right? Now they are also saying that suffix and should be less than or equals to suffix XOR. Okay, now let's worry about and here. Let's not worry about the prefix. First, let's have a look at the and part. Okay, as they said, n is odd. I'm going with 5 here. Okay, or let's go with 7. It would be better. So I'm going an array with size 7. Okay, now as n is always odd, I'm going with 7. Okay, now how can I ensure my and will not change? So first of all, as they're saying about prefix, so this is the prefix for this, and this is going to be the prefix for this, and this is going to be the prefix for this, and this is going to be the prefix for this. And similarly for suffix, this is this, and this is the suffix till this index, and this is the suffix till this index, and so on, right? Okay, now how can I ensure that my and is not going to change? I can say that I can say that let's say integer a, when I perform and with a, it is not going to change, right? It is not going to change. So here let's say I have took an element like, let's go with 3, let's go with 3, let's go with 3. Okay, now let me take all element as 3 here, because we want prefix and to be not changed. I will understand why moving forward. Now I'm taking a prefix and here. Okay, so if I take prefix and, so here it is going to be 3. What is 3 and 3? It is 3. What is 3 and 3? It is 3. What is 3 and 3? 3, and everything will be 3, right? Everything will be 3. Now, shall we take, now let's try to take prefix or, okay. Now, what is A or A? What is A or A? which is 0. Again, what is A or 0? What is A or 0? It is A, right? Okay. Now here it remains 3 because we don't have anything to compare with. Now, what is XOR till this point? You are going to XOR 3 with 3. You are going to get 0. Now you are going to do 0 XOR 3. That is nothing but A XOR 0. So you are going to get A, which is 3. Similarly, 0, 3, 0, 3. Right? Yes or no? Okay. Now, now, what is the condition for prefix and? Prefix and should be greater than or equals to prefix XOR. Okay, shall we check that? Okay, it is greater than or equals to, 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 everything matches, right? Everything matches. Every prefix and value is greater than its corresponding prefix XOR. So our first condition is met. Now let's see about the second one. So let's take suffix and as well. So I'll just write it here. I'll just write it here. Suffix and. So for suffix, it just remains 3. Now, so for suffix, we should come from ending, right? We should come from ending, so it remains 3. Now, till this point, what is the suffix and? Suffix and, right? Suffix and, it is going to be 3, right? It is going to be 3. Here, 3, 3, 3, because and will not change. Now let's see about suffix XOR. Let's see about suffix XOR. Now, at this point, we will have 3. Now, here, what is 3 XOR 3? What is 3 XOR 3? What is 1 XOR? Sorry, what is this is 3 and this is 3, right? So, what is the XOR of this? 0, right? You're going to get 0. Similarly, you're going to XOR with this, so you're going to get 3. Similarly, you're going to do XOR with 3, you're going to get 0, 3, 0, 3. Now, what is the condition? Suffix and should be less than or equals to suffix XOR. Okay, fine. Let's check that. Sub here it is greater. Now we should check for less than or equals to. Is 3 less than or equals to 3? Okay, it is equals to. Now here, coming to here, is 3 less than or equals to 0? No. So that means our second condition is not matching. Our second condition is not matching. Okay. Now what will I do is I'll just change this value as 1. Okay, I'll just change this value as 1. Now what happens to prefix and? What happens to prefix and? So till this point it is 3. That is nothing but 1 and 1. Now we are going to do and with 1. So you are going to get 1, right? You're going to get 1. So you'll have 1 here. Now you are here. Sorry, you have 0 here. And you are going to perform XOR with 1. So that is nothing but 0 and 1. So what is 1 XOR 0? 1. And this remains 0. So this is in turn 1 again. Right? Now let's try to, as we changed the array, let's try to see if the first condition is still being met or not. I can tell, right, only this value is changed. If you see, everything else remains same. Only this value is changed. And I can say that 1 greater than or equals to n, right? It is equals to. So yes, the first condition is still satisfying. Let's move to the second condition now. So this value will change. Now you know that. So, but for prefix, we come from starting, right? But for suffix, we come from ending. So we change the ending value, right? So let's try to repopulate the suffix and prefix and suffix or. Now what is, so here you are going to have one, here you are going to have one. So yeah, I'll just write it here. So it is one. Now you are going to perform 3 XOR with 1, right? What you are going to get? So let's first worry about and. Okay, let's first worry about and. Let's do and. Okay. Now what is 3 and 1? What is 3 and 1? So you are going to get 0, 1. Right? You are going to get 0 and 1. Again, what you have here? What you have here? 3. What you have here? 3. Okay. Again, you have 3 here. Until this point, the suffix and is 1. So 3 and 1. Right? You are going to get 1 again. And again 3, 1, 1, 1 and 1. Now let's start with XOR. So we'll just write 1 here because it's 1 here. And let's try to fill this value. So 1 XOR with 1 XOR with 3. That is this. So what is 1 XOR 1? 0. Now what you are going to get? 0 XOR 1. What is that you are going to get? You are going to get 1. What is this value? 2. 2, right? Right. Now again here, when you compare this with 3, what is, when you do 2 XOR 3, what is the bit representation of 3? It is 1 and 1, and you are going to do XOR with 2. That is nothing but 1 and 0. Now what is the resultant value that we get? What is the resultant value that we get? This turns to be 0 and this is 1. This is 1. Now again, what you're going to do? You're going to do XOR with this 3. So 1 again, 1 XOR with 3. And this is 1 again 0. So again, you're going to get 2, 1, 2, 1. Right? Now let's try to see the second condition. Suffix and less than or equals to suffix XOR. Is 1 less than or equals to 1? Yes. Is 1 less than or equals to 2? Yes. Is 1 less than or equals to 1? Yes. Similarly for everything. Right? Similarly for everything. Now if you see, our second condition is also met. So with this, what did you understood? With this, what did you understood? I can simply print simply print 3 from 0 to n minus 2th index, right? And at the end, at the end, at the end, you can print 1. And this is not the only combination. You can have multiple ways of doing this. Try to take different values of this, and you can just try it out by dry running the logic part here, like how we did here. So let's try to write the code for this. So before jumping to write code, let's have a look at the constraints. If you look at the constraints, the test cases are from 1 to 1000 and array size being 10 power 5 where n is odd. So at max, we are going to have 10 power 8 iterations, right? So I guess we should go with fast IO here rather than going with the scanner class. So I'm going with buffer reader and writer. So first I'm going with buffer reader. I'm creating a buffer reader object. So taking from the console. So let me create the buffer writer object as well. So I have created the buffer header and buffer header objects. Now, as per the input format, I'm going to read the t test cases here. So t. So whatever the input we read using buffer header and buffer header is going to be in terms of string, right? So I'm going to typecast it. So first of all, I'm reading it using reader object. Then I will typecast it to integer using integer dot parse int. So I'm parsing the string to integer. So this is done. I can reuse this code. Now while t minus minus looping over test cases. Now for every test case we are going to receive n. For each value of n, I will iterate from 0 to n minus second index I plus plus, and I am going to print or write 3 with a space, and at the n minus 1th index I am going to write 1 along with a new line. So it start printing the new line for the next test case. So once the printing is done, I will flush the memory. That is bw.flush. Now let's run. So we are getting a comma which we don't want. Now I'm running. Yeah. Now let's submit it and check. So it got accepted, if you see. That's it guys. Thanks for watching the video. If you found it informative, make sure you share the video with your friends and don't forget to like, subscribe and share our channel. See you in the next video. I'm Nikhil signing off.